So this example here, we're going to look for the inequality. In other words, we're going to have to probably find at least a domain of x in this question. So they're looking for us to solve for that. Right now they've given us some linear function, and it says the linear function is greater than 20, but we don't know exactly what x is greater than, what our variable is. So we're going to isolate for x, okay? So when we're adding or subtracting, it's exact same rules, okay? We just bring it to the other side of the equation. So we end up with negative 2x is greater than or equal to 20, subtract 35. That's going to give us negative 2x is greater than or equal to negative 15. Still, exact same idea also. If we're trying to isolate for x, I'm going to divide both sides by whatever coefficient is in front of x. So we would divide, in this case, both sides by negative 2. Now, had this number been, let's say, just 2, we'll do an example in blue on the side. Had this been 2x is greater than or equal to negative 15, I would have divided both sides by 2, okay? And our inequality would have stayed the exact same. We would have got x is greater than or equal to negative 15 over 2. So what's important to notice here is this stayed the exact same. But because we're dividing by a negative number, and same goes for multiplying by a negative number, whenever there's a negative involved, our inequality is going to change directions, okay? So this then becomes x is less than or equal to positive 15 over 2, which is 7.5, okay? So x is less than or equal to 7.5. So we're assuming this is a linear function because the exponent, our variable is to the exponent of 1. So in other words, it's continuous. So if I wanted to put a domain on my x, what it's happening is it's saying that this function, our domain, is x is every real number such that x is, and whatever our inequality was at the end, less than or equal to 7.5. Okay, this was what, 2e? So this is question 2e from your work. Again, we're looking for x. What you did is you solved it on the left side, so you quickly brought the x over. You ended up with negative x minus x is greater than, and when you brought the 1 over, you got 1, subtract 1, negative 2x greater than 0. And when you want to divide this, because it's a negative, your sign is going to have to flip. Okay? So you end up with x is actually less than 0 in this instance. Is that what? Now let's say we decided to bring the variable to the other side. Let's take a look at what that would be. Negative x plus 1 is greater than x plus 1. Let's say we reversed it. I brought the negative x to this side and the other one over. I would still end up with 1 subtract 1 is greater than, this time it would be x plus x. 0 is greater than 2x. And when I divide by 2x, that's not going to change anything because the number is, or sorry, not 2x, but divide by 2. I get 0 is greater than x. And in both cases, the signs are just read in different order, but they still mean the same thing. This one's saying x is less than 0. This one's saying 0 is greater than x. Exact same idea. It's easy. This is your fourth example here. Example 4. Okay. In this instance, if you notice, we have a constant and a constant. So this is like when we're finding between numbers. We know that our variable x, which lies always in the middle, is going to be between these two numbers. Okay, but things are going to change because there's a lot of other variables involved in this. So actually what we're going to focus on is simplifying the middle of this. Okay, so our first step, will be to distribute our numbers into the brackets. Okay, so we end up with 30 less than or equal to 6x plus 12 minus 2x minus 2 less than or equal to 46. That makes sense so far? Okay, so we've distributed it. Now we're just going to collect our like terms. Okay, 30 is less than or equal to, we have 4x plus 10 is less than or equal to 46. Okay, so when we go to move the 10 outside, because it's a positive 10, we're going to be moving it outside and moving it outside. So assume like it's one side of the equation, but what happens is as soon as we move it, it has the opposite effect of the number would normally. So it's the same idea if there was only one side, like assume this was gone. When we move it, it becomes negative 10. But because this is actually in play, it becomes negative 10 on this side and negative 10 on this side. Okay?
Oh, okay.
So we're moving it out of both. So what ends up happening is we have 30 subtract 10 is less than or equal to 4x less than or equal to 46 subtract 10. I had to subtract 10 from the other two sides of the equation. I had to have it done twice. That makes sense? And then finally we end up with 20 is less than or equal to 4x less than or equal to 36. Same idea again. Whatever you do to one side of the equation, technically we have three sides here. Whatever you do to one side of the equation, we have to do to the other sides. So we want to isolate for just x. So I'm going to divide by 4, and I'm actually going to divide every term by the number 4. Okay, so I end up with 5 is less than or equal to x, which is less than or equal to 9. Okay, so what they're saying is they have some equation that on a number line would fall between the numbers, so we had 4, 5, 6, 7, 8, 9, 10. The only values, let's do a good one. The only values of our number are in here. Okay, so we exist in terms of a domain for x. X is every real number, such that, and we write exactly what our inequality is, less than or equal to 9 and 5.
Okay.
Does that make sense?
Yeah.
So here's another example. They're asking you to create an inequality with variables and constants on both sides. So they want this to be the answer. X is less than negative 5. Okay? But they want you to create this so that there are numbers on both sides. So essentially what you're going to do is you actually want to work backwards, constantly splitting these answers. Okay? So they want variables and constants on both sides. A variable is just, this would be a variable, a symbol for a number unknown, and a constant would be just a number like, let's say 26. So, this is an example of a variable and a constant, okay? So what we're going to do to make sure this works is I'm actually going to break these up. So how can I break up positive 1x? I could make it a subtraction. I could make it a division. What I'm going to do is I'm going to actually do 5x subtract 4x, okay? So I've split that. I know that x is the answer to that, but I've split it. Same idea with negative 5. I'm going to split negative 5. How could I get it? Well, I could get it by adding. I could add negative 15 plus 10. These are just arbitrary numbers, okay? Now that I've done that, I've created, because we have two sides of an equation, right? We have left side and right side. They want a variable and a constant on both sides, which is fine. I can now manipulate this equation, or let's say I bring the 4x over and I bring the negative 15 over the other way. So I end up with 5x plus 15 is less than 4x plus 10. So because I've worked this all out backwards, I know that this is eventually going to become 5x is less than negative 5. But I have a variable on both sides and a constant on both sides. And I can check this. We'll do it in red. 5x plus 15 is less than 4x plus 10. Okay, let's move the 4x over. I get 5x minus 4x. I get negative 15 plus 10. X less than negative 5. I got the exact same answer. All I did was split things and move them around. That makes sense?
So I could make any numbers.
Any numbers, as long as they equate to the solution they've originally given us.
So basically, there's probably a million
solutions. They just want to make sure it works. So usually in instances like this, they ask you to make the solution and then check for it and prove it through your checking that it works. Okay?
Yeah.
That makes sense?
Okay.
Alright, we have a double inequality. Same idea. Do they ask for anything specific like constants and variables in each term? What does it say?
Could I say write the solution using set notation, create a double inequality for each which this is the solution set.
Okay. technically we can just constantly, because remember the example we did, they only broke the middle, right?
Mm-hmm.
Now technically I could put things on the outsides too. Just whatever I do to them, I'd have to do to the other sides. So for instance, we can break the x into, let's say we had 5x divided by x, okay? That would still give me 1x less than equal to 19. Now in order to get rid of that 5, I'm going to have to multiply this term by 5, this term by 5, and obviously our middle by, well, I don't know why I made dollar sign, by 5, okay?
Mm-hmm.
So in which case we end up with 75 less than equal to 5x less than equal to 95, okay? So now I have that. And now I could split the number in the middle again. I'm not sure how far they really want us to go with this. This could become, this could become 15. I'm trying to think of a way to do this differently.
Is there an easier way?
Oh, there's a million different ways.
Okay.
Okay, I'm just trying to actually do a for example. Another thing we could do is we could add the number 10 in. Okay, we'll do that in red. So say we're going to add the number 10 in this inequality. Well, whatever I do to the insides, I'm going to have to do to the outsides of this equation. So my 95, I'm going to have to add 10 to. Then I'm going to have to add 10 to my 75. Okay, so I end up with 85 less than equal to 5x plus 10, let's say, and equal to 105. And finally, I could even split the middle up a little to make it a distributive property question. I'm going to take the 5 outside, I have x plus 2 inside of it.
Wouldn't it be minus 10? Because you're bringing it to the...
Oh, sorry, yeah, you're right. We'd have to minus 10 if we... No, because the 10's in the middle, and we've created it, when I go to take it out, so when I finally get to move this 10 out, I'm going to have, it's positive in here, but when I take it to the outsides, it's going to have to become negative. Sorry, not like that. That says negative 85. It's going to have to become negative 10 plus 85, and negative 10 here. That's going to take us back to our 95s when the 10 no longer exists. So it's going to take us back to here. Okay? So think of it, whatever you do, you can do the entire equation, especially because we're creating an inequality. Let's just continuously keep doing the same thing over and over. So, this one, from this step to this step, all I did was create a 1. I didn't have to do anything because this is still technically 1. It's then I wanted to get rid of the divided by 5 that I had to multiply on the outsides. Okay? I made a difficult inequality from the beginning. You can do it any way you really like because I don't think they gave you any requirements. Okay, from here we're going to work with the inequality. This time I'm going to just go through the rule of whatever you do to a part, consider these 3 different parts. We have left side, middle, right side. Okay, whatever you do to one part, you got to do everything else. So I'm going to want many different constants. Okay, let's say I'm going to multiply by 3. I'm going to multiply everything by 3. So my next line reads negative 9 is greater than or equal to 3x, which is greater than or equal to negative 36. Okay. Now what we said is we wanted a variable everywhere, right? So what I'm going to do is I'm going to split this 3x. It's still going to be 3x, but in this case it's 2x plus x. Okay? Negative 36. Now, I don't have to obviously split these because this is still equal to that. I haven't changed it drastically like a ratio. Next what I'm going to do is this x, I'm going to move it. Okay, so I'm going to move the x to the outsides. And remember, you're going to have to do it to both when you go to move it out. So that x becomes negative x. So I get negative 9 minus x, okay, less than 2x, less than or equal to negative 36x minus x again. Okay? And finally, we wanted a constant everywhere, right? Well, I've decided I'm just going to add the number 2 into the middle. So if I do that to the middle, I'm going to have to add the number 2 to all the other ones. So I now have negative 9 plus 2 minus x greater than less to 2x plus 2 greater than less than negative 36 plus 2 minus x, and I'm just going to have to simplify the outsides of the equations. Negative 7 minus x less than equal to 2x plus 2 less than greater than and equal to negative 34 minus x. Okay, so here's an inequality where I have a variable constant, variable constant, variable constant on all three parts. And then it can be simplified way back to the original inequality that we started.
Do you have to add 2, or can you just leave it like that?
You could do anything you really want. Well, I was going on the assumption that they wanted a variable and a constant in all three parts. So because I only had a variable here I had a constant variable, I decided to add a constant to the middle, which caused me to do a little more work on the outsides. Okay, so I went on the assumption that they wanted one of each. Remember, like question 8 said that? Give a variable and constant on each side. I went on the assumption that they wanted that too. So why don't we do that too, just so it looks like a complicated question, okay? So what you did is you worked out by pushing 22 in the Celsius and 18 in Celsius and solving for Fahrenheit. Another way we could work this inequality is work them side by side. So we have our 18 less than equal to x less than equal to 22. And what I'm going to do is on the side, so we'll call this our equation 1, and this is our equation 2. I'm going to manipulate the inequality the same way I would manipulate my Fahrenheit, okay? My Celsius Fahrenheit equation. So let's think about it. What would my first step be in order to isolating f? Trying to isolate f, what is the first thing I need to do?
To bring the 32 over to C.
Actually, I can't bring the 32 over yet because it's in the brackets. I got to deal with that's outside of the brackets first.
So then you just flip it over, like the 9 and the 5.
Yeah. Okay. Let's do it one step at a time.
Okay.
Technically, this is an entire thing divided by 9. So in order to move the 9 over, what would I have to do? Yeah. So I'd have to multiply this by 9. Okay. So it'd have to be c times 9. And now what I'm going to do? So I'm going to multiply this entire equation by 9. Okay. So in our next step, we have 9c is equal to 5 f minus 32, right? And over here, 9 by 18, 162, is that right? I should get a calculator out for this, but and that will be 18 carry the 1, 198. Are those two numbers right?
Yep.
Both of them? Okay, great. Our next step is our 5. Okay, because yeah, that's right. I'm gonna have to divide this side and this side by 5. So our next step over here, good, you're already a step ahead of me. 9 over 5c is equal to f minus 32. What are we going to get over here?
32.4.
32.4. This is going to, oh, sorry, I also forgot to put 9x there. And this will become 9x divided by 5, okay? Less than equal to
39.6.
39.6.
Yeah.
Okay. And finally, the last part of our inequality is I need to bring the 32 over. So it becomes 9 over 5c plus 32 is equal to f. Okay. So when we add those numbers there, what do we end up getting? I think
0.4.
0.4 for which? Oh, no, we have to add it.
Oh, yeah.
Yeah. We're still going to be short.
64.
Second, okay, so we ended up with 64.4 less than equal to 9 over 5x plus 32 less than equal to 71.6. So this is an inequality with the equation involved inside, okay? So this is where our equation right here is actually involved in the inequality, and these are our outside terms. Now, they weren't the same terms we looked for our Fahrenheit, but if we were to go to plug our numbers in, then we would go to find out if this works, okay? So this one, we included the equation. Okay, so we actually did have the right Fahrenheits. These two numbers are our Fahrenheits because we manipulated the equation the same way we would have manipulated it on this side. Does that kind of make sense, that idea? And then these Fahrenheits we just had wrong to start. Those are the actual Fahrenheits we're looking for.
Yeah.
Okay?